In this video, we're going to learn about multiplying and dividing radical expressions. We're in section 6.4 of Al Grosch's book, Developmental Math 2. All right, so there's one thing that we need to talk about with multiplying radical expressions, and that's really the one rule that you need to multiply is outside times outside, inside times inside. And what I mean by outside and inside are the numbers in the expression. The outside numbers are the coefficients. The inside numbers are the radicands. So to multiply any radical expression, you multiply the coefficients first. So in this case, 4 times 5 would be 20. And then you multiply the radicands. 6 times 3 is 18. And that's great, and you're done unless your radicand can be simplified. And in this case, the 18 can be simplified. So we separate into the perfects and the not perfects. 18 is 9 times 2. The square root of 9 is 3, so that's going to get multiplied times the 20. And we end up with 60 times the square root of 2. And that's the basics of multiplying radical expressions. So we'll do some more examples down here. Square root of 5 times 3 square root of 2. When I multiply the outsides, or the coefficients, I have 3 times the invisible 1 here. So 3 times 1 is 3. And when I multiply the radicands, I have 5 times 2, which is 10. Square root of 10 does not simplify, so I'm done there. On the second example, same type of thing. I have the invisible 1's in the front, so 1 times 1 is 1, and you don't need to write the 1 coefficient. But in the radicands, I have 6x times 8x, which makes 48x squared, which needs to be simplified. The 48 is 16 times 3. The x squared is perfect, and the square root of 16x squared is 4x, so I have 4x square root of 3. I think in the newest version of this book, these last two examples are actually on the next page, so flip to the next page and see if you see them there. All right, so coefficients first. 2 times 3 is 6, and then radicands. 5x cubed times 4x to the 6 is 20x to the 9. Don't forget, when you're multiplying, you add those exponents. And we need to simplify. 20 is 4 times 5, and x to the 9 will be broken down to be x8 and 1 extra. The square root of 4x8 is 2x to the 4th. Multiplied times that 6 gives us 12x to the 4th. And the not perfects, they just come straight down. In this example, same thing, coefficients first. So 4 times 3 is 12. And radicands, 2x times 14y makes 28xy, which needs to be simplified. So 28 is 4 times 7, and the x and the y only have 1 each, so they won't be able to be simplified. They have to stay in the not perfects. The square root of 4 is 2, times that 12 out front, gives us 24 square root of 7xy. Okay, here's a concept at the top of the page here. The square of a square root is x. Okay, in other words, it's the same as the radicand if the radicand is positive. When the radicand is negative, that's a whole other topic for another class. The square root of x, when I square it, equals x. Because the radical and the exponent 2 are opposite operations, they cancel each other when the radicand is positive. And you just end up with whatever the radicand was when you perform opposite operations on the same number. So the square root of 5 is some kind of decimal number we can make an approximation with, but whenever I take that number and I square it, I'm going to get 5 back because that's the definition of what a square root is. The square root of x minus 3, when I square it, will still be x minus 3 because the square root and the square cancel each other. All right, now you have to be careful on this last one because the square is on both the coefficient and the radicand, but the square root is only here on the 2. So if I kind of separate this out, this 3 is going to get squared, and the square root of 2 is getting squared. Well, the 3 squared makes 9. The square root of 2 squared, these functions are going to cancel, and we're going to have 9 times 2, which is 18. All right, now to multiply radical expressions when there's more than one term, we're going to do distributive property. So this monomial on the outside times this one, and then this times this one. This is distributive property. However, when you do this term times this term, you have to do outside times outside, inside times inside. And then when you do this term times this one, outside times outside, inside times inside. And after you do all that multiply, then you have to simplify. So we're going to try it on a few examples down here. Well, where are they? On the next page. Okay, here we have a binomial times a binomial, and again, it's going to be the same process that we use with variables. You may have learned this as FOIL. I call it double distributive, but you're going to multiply the first term times the first term in the second binomial, then times the second term in the second binomial, then the second term times the first term, and the second term times the second term. Like I said, you may have learned this as FOIL. Usually we're doing this with x's or variables. It works the same way with radicals. However, when you multiply two terms together, you do outside times outside, inside times inside. If there is no inside, it's implied to be 1. If there's no coefficient, it's also implied to be 1. So now we have some examples to work on. So first, this is distributive, so we're going to go from here to here first. And we're going to do outsides first. So 4 times 3 is 12. And then insides. 5 times 5 is 25. And that will simplify, but we'll do the simplify in the second step. Then we're going to do 4 times 6, because 6 is a coefficient here. 4 times 6, or negative 6. And then the square root of 5 doesn't really have anything here to multiply with, so it just stays the square root of 5. Now we're going to simplify. We know the square root of 25 is 5, so 12 times 5 is 60. The second term doesn't simplify, so we have 60 minus 24 square root of 5. Now I want to caution you. One of the most common mistakes I see is students then subtracting the 60 and the 24. You do not want to subtract these. These are not like radicals. Remember, to do any add or subtract, they both have to have the same radical. This will have to have a square root of 5 on it to be able to subtract with this. Do not subtract the 60 and the 24. This is done. Cannot simplify it any further. So let's try it again here. We're going to do outside times outside. So that would be 1 times 7 is 7. And then inside times inside will be square root of 2 times square root of 9 makes square root of 18. Then we'll do the same thing here. Outside times outside is 1 times 1. 1 times negative 1, maybe. So that would be a negative sign. Inside times inside will be square root of 16. And we can simplify both of these terms. 18 is 9 times 2. So that would be 7 times 3. Square root of 9 is 3. 21 times the square root of 2. The square root of 16 is 4. So we're done here. All right, we're going to try it again here. I'm going to multiply here. Outside times outside will be 2 times 1. Inside times inside will be 3x times 4x. So 12x squared. And then outside times outside here will be 2 times negative 3 is negative 6. And inside times inside will be 3x times x squared, or 3x cubed. And then we're going to simplify. 12x squared, 12 is 4 times 3, x squared is perfect. So 2 times 2x is 4x, and the not perfect, 4x times the square root of 3. In the second term, the 3 cannot be broken down. There are no perfect square factors, but the x cubed can. the x cubed could be x squared times x. So this turns into 6 times x, or 6x, times the square root of 3x, because the not perfects come straight down. And unfortunately, it looked like they might have been like radicals, but they aren't, because this one doesn't have the x on it that this one does. All right, so we've got some more multiply on this page, but this time we have a binomial times a binomial. So we're going to use FOIL, if you learned it that way. I like to call it double distributive, which means we're going to multiply these two terms first. Outsides will be 2 times 1. Insides will be 3 times 5. Then we'll multiply these two terms. Outsides will be 2 times 2. Insides is a negative 3, and there aren't any insides. I'm sorry, the square root of 3, so we'll just leave that as a square root of 3. And then we will go to here. Be careful here, because this 5 is a coefficient, but this 5 is a radicand. They will not multiply together. The outsides will be 5 times 1. The inside will just be square root of 5. And then here, 5 times 2 is 10. After we do the multiply, just when we're doing same as when we're doing polynomials, we look across to see if there are any like terms, like radicals, anything that can be added to simplify, and in this case, they are all unlike. So we're done. All right, for this one, here to here first, outside will be 3 times 2, inside will be 6 times 6, and that will simplify. We'll do it in the second step. And then here to here, outside will be 3 times 5. Inside is just square root of 6. And here times here, outside is negative 2 times 2, negative 4. Inside, square root of 6. And here to here, negative 2 times 5 is negative 10. And then we're going to simplify. So this square root of 36 is actually 6. So this turns into a 36, or 6 times 6. These two terms are like radicals, positive 15 square root of 6 and negative 4 square root of 6. So positive 15 minus 4 is positive 11 square root of 6. And we also have this negative 10. If you think you're done, you need to look carefully, because this 36 and this negative 10 are also like terms. So when I add them together, 36 minus 10, I get 26. Plus 11 square root of 6. And just like I said before, one of the most common mistakes I see is students adding these coefficients out here. You cannot add these because this one has a square root of 6 on it and this one doesn't. So you're done here. This is the final simplified product. All right, the next example looks a little differently because it has an exponent on the outside of the binomial. All that means, if you remember your polynomial rules, is that we should use this binomial, square root of 7 minus 3, twice. So that's what we're going to multiply. We're going to multiply square root of 7 times square root of 7, and they're both on the inside, so that makes square root of 49. Square root of 7 times negative 3, the negative 3 is outside, the square root of 7 is inside. Same thing here, negative 3 times square root of 7. And then at the end, negative 3 times negative 3 makes positive 9. Simplify, square root of 49 is 7. These two terms in the middle are like radicals. So negative 3 plus negative 3 makes negative 6 square root of 7. And I have a positive 9 here on the end. So again, being careful because the 7 and the positive 9 are like terms. So when I add them together, I get 16, and then I have the negative 6 square root of 7. So binomials again here. Outside's going to be 4. The inside is 3x times 3x, which is 9x squared. And then when I go here to here, outside is negative 6. Inside is square root of 3x. And then here to here, outside is negative 2 times 4 is negative 8. Inside, square root of 3x. And then here to here, negative 2 times negative 6 is positive 12. So now some simplifying. Square root of 9x squared is 3x. So that makes 12x. These are like radicals. Negative 6 minus 8 is negative 14, square root of 3x. And we have this positive 12 on the end. And that looks like it, because this time these two terms are not like terms, so we won't be able to add them this time. Okay, now we're going to do some division. Don't let it freak you out because they look like fractions. It's no big deal. There's this rule when you're dividing radicals. I'm going to write it right up here. That says if you have two radical expressions being divided like this, it's okay to put them back together and make one division out of them, which is exactly what I'm going to do here. I'm going to put these back together and write this as 40 divided by 5, which of course is 8. So this turns out to be the square root of 8, which can simplify because 8 is 4 times 2. So this simplifies to make 2 times the square root of 2. So we'll do the same thing here. We can put these together and write this as 84 divided by 3. Now, just to make this clear, it's only useful if these numbers are divisible. If 84 was not divisible by 3, this probably wouldn't help me, but it is. So what is 84 divided by 3? I believe it's 28. And 28 simplifies to be 4 times 7, so 2 times the square root of 7. All right, in this next example, we're going to do the same kind of thing. We're going to put these two expressions together under one big radical, and then we're going to simplify this resulting rational expression. So I'm going to leave the radical there. 32 divided by 2 is 16. And x to the 6th divided by x squared, if you remember those rules, you subtract those exponents, leaves you with 16x to the 4th. And this is a perfect square. The square root of 16 is 4. The square root of x to the 4th is x squared. So we have 4x squared. Let's do the same thing here. Put these together. 200 x to the 11 over 4x. And we will divide. 200 divided by 4 is 50, and x to the 11 divided by x is x to the 10. Now, this is not a perfect square, but we can simplify it because we know 50 is 25 times 2, x to the 10 is perfect. So the square root of 25 is 5, the square root of x to the 10 is x to the 5, and then we have the square root of 2 hanging on. Okay, on this page it looks like we're going to do some applications. Find the area of the rectangle. Well, we first have to know how to find the area of the rectangle, and there's a formula. Area equals length times width for a rectangle. In this case, it looks like the length is 4 times the square root of 6, and the width is 5 times the square root of 3. So to find the area of this rectangle, we need to multiply those two expressions together. So the area will equal 4 square root of 6 times 5 square root of 3. If you remember the rules for multiplying, outside times outside. So 4 times 5 is 20. Inside times inside would be 6 times 3, which is 18. And we're not done because this square root of 18 will simplify. So we have a 20. The 18 is 9 times 2. The square root of 9 is 3. That's going to get multiplied times the 20. So we have 60 square root of 2. So the area equals 60 square root of 2, and the units are feet. So we'll put the units on there. Square feet, since it's area. Got the same kind of question here. Find the area of the rectangle. Remember that area equals length times width. In this case, the length is 2 square root of 3 plus 5, and the width is 4 square root of 3 minus 6. So the only thing different here is these are binomials now. So to multiply them, we're going to use FOIL or double distribute because they're binomials. So we need to multiply this term times this term. Outside is 2 times 4. Inside is 3 times 3. And then this times this. Outside is 2 times negative 6. Inside is just negative square root of 3. And then this times this. Outside is 5 times 4. Inside is square root of 3. And this times this will be 5 times negative 6 is negative 30. And we're going to simplify. The square root of 9 is 3, so 8 times 3 is 24. These two terms in the middle are like radicals. They both have square root of 3 on them. So negative 12 plus 20 makes 8 square root of 3. And then we have this negative 30 on the end. We're not quite done because the 24 and the negative 30 are like terms. So we're going to have 8 square root of 3 minus 24 plus negative 30 makes negative 6. And we're going to put units on. This is square feet again.